What's going on? Again, everyone, Samaj. This is Samaj. Welcome to part 3 of how to solve for missing properties of a liquid, thermodynamics edition. So, for this problem here, we are given a pressure of 1000 psi, a temperature of 200 degrees Fahrenheit, and we are trying to find specific volume, the enthalpy, the quality, and the state of water, which is the liquid that we're given. So let's go. First rule, always do this. This is what I always do. I always assume saturated liquid as the state, just so that I have something to go off of. I need a reference. So let's go to the saturated water table. I have a pressure, so I can go to the saturated, well, I'm already in saturated temperature table. I have a temperature as well. So let's go 200. Look at the pressure there, see if it matches. We see that at a pressure of temperature of 200 degrees Fahrenheit, the pressure here is showing 11.538 psi. Now, we see that our pressure is 1000 psi. That is not a match. So, that's not a good sign. That might mean that we are not in the saturated liquid region. But just to be sure, let's go to the pressure table and let's match our pressure with our temperature. So we're going to go down to 1000. Alright, there's 1000. And the temperature here is 544.65 degrees Fahrenheit. And we go back here, we look at our temperature. Our temperature is 200 degrees Fahrenheit, so that is not a match. So what do? It's not a saturated liquid. Well, the water is not in a saturated state. So now we have noticed that. Okay, so now we have to make another assumption. It's going to either be, it's no other choice. It's either going to be a compressed liquid or it's going to be in the superheated region. It's going to be superheated. Since I see that the temperature is fairly low, 200 degrees Fahrenheit, I'm just going to assume that it's a compressed liquid. So let's go over to the compressed liquid table. Let's set up superheated water. Okay. Now we look for temperature of 200 degrees at peak pressure of 1000 psi. Here's the pressure of 1000 psi. Here's temperature of 200, and we see that our specific volume is hold on. I want to get this here. Okay, so our specific volume is 0.016580. Okay, that's cubic feet per pounds of mass. And now we're going to look up our enthalpy. See, when water is in a compressed liquid state or superheated state, it's a lot easier because you don't have to solve for the quality. You don't have to rearrange any subjects. You just pull numbers straight off of the charts. So the enthalpy is 170.8. 170.38 actually. Enthalpy equals 170.38. Okay. So now we have our specific volume, we have our enthalpy, we have our state, which is, I'll write that over here. And how do we know that water is in a compressed liquid state? Well, because our numbers matched up. So we see that we have a temperature of 200, we see we have a pressure of 1000 psi, which is what was given to us over here. So yeah, we got a winner. And equality is going to equal 0. And the reason why is because if we look at the phase diagram that I drew, this is the saturated mixture region right here. This is anything quality here is between 0 and 1. We're on the compressed liquid side, so can't have a negative quality. So it just stays at 0. So that's what we have. That's all. We found the specific volume, the enthalpy, the quality, and the state. If you have any other questions for me, you need me to clarify something, hit me up in the YouTube comment section. I'll get back to you. Alright, have a good one.